Hello, my dear students. So today we are going to discuss about the atom, its symbol, atomic structure, different subatomic particles, atomic number, atomic mass, and other properties of atom. So let us start with the very first topic, that is the definition of atom. What is atom? How can we define atom? So the atom means the smallest particle of element that retains the identity and properties of the element is called atom. So this definition tells us that atom is the smallest particle of every element that retains the identity of that element. And while retaining the identity, it also shows the properties of that element. So this atom, the word atom is actually derived from the Latin, which means here atom can be divided into a plus tum. Here tum means to cut, and whenever we add a, it means the negative meaning. That means we are unable to cut something, then that is called atom. So when atom was discovered, then it was believed that it is not divisible into small form. That is why the name atom was given. Now let us see the structure of atom. When we talk about the structure of atom, then an atom has mainly neutron, proton, and electron. Here, neutron and proton. N represents neutron. P represents proton. These neutron and proton are located in the central part of the atom collectively. So, these neutron and proton are together known as nucleus. Since they are known as nucleus, here we can also call them nucleons. Neutron and protons are also known as nucleons. Whereas the electron revolve around the nucleus of the atom in a circular or elliptical path. That path in which the electron revolve is called shell or orbit. This shell or orbit is an imaginary space in which the electron keep revolving around the nucleus. So this electron is not permanently placed in a fixed place, but it keeps revolving around the nucleus. And while revolving, it occupies certain space, certain path, that is called shell or orbit. Here E represent electron. Now these three particles, electron, proton and neutron, They are collectively known as subatomic subatomic particles. Subatomic particles. So what are the three subatomic particles present in the atom? They are electron, proton, and neutron. This electron, as it revolves around the nucleus in elliptical or circular path, is the lightest particle, whereas neutron is the heaviest particle, but this proton, it is heavier than electron but lighter than neutron. So we can write that heavier than electron but lighter than neutron. Now when we talk about the charge of these electron, proton and neutron, then this electron is negatively charged, whereas the proton is positively charged, and this neutron, it is neither positive nor negative. It is neutral or chargeless. Now we have to remember one thing, that in every atom, the number of proton and electron is always equal. Number of proton is equal to number of electron. Since the number of proton, that means positive charge, and number of electron, that means negative charge, in every atom is equal. An atom is always electrically neutral or chargeless. So this is very, very important. Most of the time it is being asked why an atom is electrically neutral or chargeless. So what is the reason behind that? An atom always contains equal number of positive and negative charge, that means equal number of proton and electron. So positive charge and negative charge cancel each other and the net charge become zero, due to which an atom is electrically neutral or chargeless. Now let us talk about these subatomic particles. Electron, represented by E, proton, represented by P. Here we can write E power minus, P power plus, and neutron, N. Since it is chargeless, we can write N power 0. Now, what is the charge of this electron, proton and neutron? Since neutron is chargeless, we can write 0 charge. Electron, it is negatively charged, so minus 1.6 into 10 to the power minus 19. Whereas proton is positively charged, so plus 1.6 into 10 to the power minus 19. Here the relative charge of this electron, proton and neutron. relative charge is -1, +1, and 0. Now, if we talk about the mass in gram and atomic mass unit, atomic mass unit, then this electron, it is the lightest particle and its mass in gram is 1.67 into 10 to the power -28 gram, whereas proton 1.67 into 10 to the power -24 gram, and neutron also nearly the same, 1.67 into 10 to the power -24 gram. If we talk about the mass in AMU, then in case of proton 1.007, whereas in case of neutron 1.008. But in case of electron, its relative mass is 1 by 1837 is the atomic mass unit, AMU. So this is about the subatomic particle. As I have told you about the charge or relative charge, number of electron, proton and neutron in the atom. Here, neutron number may differ from proton and electron, but number of electron and proton in every atom is always equal. Now, after this subatomic particle, let us talk about some properties of atom. The first one, the symbol. What is the symbol? Every atom has short name, and that short name is obtained from the full name of that atom. Some of the short name is derived from the Latin words of those atom, whereas some of them are derived from English word or some other language words. So, symbol means the short form or short name obtained from the full name of atom. Full name of atom is called symbol. Like if we talk about hydrogen, what is the symbol of hydrogen? Symbol of hydrogen is H. It is taken from its full name. The first letter of the full name is H. So we use it as the symbol of hydrogen. Similarly, we have sodium. In case of sodium, the symbol of sodium is Na because its Latin name is natrium. Natrium is the Latin name, and since natrium is the Latin name, the first two letters of natrium are taken as its symbol. So the symbol of sodium is not SO or not S, but it is Na. Similarly, potassium, its symbol is K. Why the symbol of potassium is K? Because its Latin word is kalium. And from that kalium, first letter K is taken as the symbol of potassium. Now, mercury. What is the symbol of mercury? It is Hg, and its Latin name is hydragyrum. Hydragyrum. And from that hydragyrum, H and G are taken as the symbol of mercury. Similarly, the symbol of gold is Au. Its Latin word is aurum. Symbol of silver is Ag. Its Latin name is argentum. That's why Ag is the symbol of silver. Here one element is there whose name is derived from German word, neither Latin word nor English word, but its name is derived from German word, that is tungsten. Tungsten symbol is W and its German word is Wolfram. This one is the German word from which the symbol W is taken as the atomic symbol of tungsten. Now, there are many other elements and every element has their unique symbol. No two symbols of atoms are same, but they are different. So after the symbol of element, let us talk about the next property of atom, that is atomic number. What is atomic number of any atom? Whenever we talk about atomic number, then how do we define atomic number? Atomic number is represented by the letter Z, and it means the total number of proton present in any atom is known as the atomic number. The total number of protons present in any atom is called atomic number. Here one thing we have to keep in mind, that in every atom the number of proton and electron are same. So if we know the atomic number, then we can easily find the number of proton and electron present in that atom. Suppose if I say the atomic number of sodium symbol Na, and if I write Z is equal to 11, what does it mean? It means sodium has 11 protons, and not only 11 protons, also 11 electrons. But we can't define atomic number as the number of electrons present in any atom. We always have to define that atomic number means what? Number of protons present in any atom. Okay, after atomic number, we have another property, that is atomic mass. Atomic mass represented by the letter A. Here, this atomic mass means the sum of the masses of neutron and proton present in any atom is known as what? Atomic mass. This atomic mass, it can be calculated by adding the mass of proton and mass of neutron present in any atom. We can write A is equal to proton plus neutron. Actually, the number and mass, relative mass, are nearly the same. So we can write number of proton plus number of neutron also. But while writing the definition, we have to say the sum of the masses of proton and neutron present in any atom is known as what? Atomic mass. Now, how to find atomic mass of any element? For this, we have to know the atomic number of elements from 1 number to 20 number. What are the elements from 1 number to 20 number? You know, in 1 number there is hydrogen. Symbol H. 2 number helium. Symbol He. 3 number lithium. Symbol Li. 4 number beryllium. Symbol Be. 5 number boron. Symbol B. 6 number carbon. 7 number nitrogen. 8 number oxygen. 9 number fluorine. 10 number neon. Symbol of carbon C, symbol of nitrogen N, symbol of oxygen O, symbol of fluorine F, symbol of neon Ne. After that, 11 number, there is sodium. 12 number magnesium. 13 number aluminium. 14 number silicon. 15 number phosphorus. Sulfur. Chlorine. Symbol of sodium Na. Mg. Al. Si. P. S. Capital C, small l, Cl. If we go to 18 number, there is argon. Symbol Ar. 19 number potassium, symbol K, and 20 number calcium, symbol Ca. So first of all, we have to remember these 1 number to 20 number elements with their symbol. This serial number is equal to the atomic number of that atom. It means what? If we talk about nitrogen, it lies in 7 number. Then how many protons are there in nitrogen? Since it lies in 7 number, its atomic number is 7. It has 7 proton and 7 electron. Now we will talk about the number of neutron present in these atoms. There is one trick to remember the number of proton present in different atom from 1 number to 20 number, so that we will be able to find the atomic mass of element from 1 number to 20 number. Now, number of neutron. If the atomic number is if the atomic number is odd, then number of neutron n is equal to number of proton plus 1. If the atomic number is even, then number of neutron is equal to number of proton. This rule is applicable from 1 number to 20 number, but here we have some exceptions. I will write that in which element it do not apply. In 1 number, hydrogen. Hydrogen is the element where there is no neutron. In 1 number, no neutron. So we will not apply this rule to 1 number. Then in case of beryllium, number 4. Number 4 also, this rule is not applicable. We have beryllium atomic number 4. It is even number. That means number of neutron and proton should be equal. But it is not like that in case of beryllium. Here in beryllium, though the number of proton is 4, it is even number. The number of neutron in beryllium is 5, which is similar to the odd number case. So this 4 number we have to remember. After that, 7 number, nitrogen. It is odd number, but we apply in nitrogen this even number rule. Okay, and then another we have number 18, where this rule is not applicable. Also in number 3, this rule is not applicable. But generally, we have to find the atomic mass of elements other than these element which I have marked. Now, if we talk about oxygen, what is the atomic number of oxygen? It is 8. It means how many proton are there? 8 proton. Then how many neutron there should be? First of all, we have to see this 8 is odd number or even number. It is even number. In case of even number, what happens? Number of neutron is equal to number of proton. So what is the number of neutron here? 8. So what will be its atomic mass? Number of proton plus neutron. That means 8 plus 8. It is 16. Here we can apply this rule. Similarly, if we take another element, suppose sodium. What is the atomic number of sodium? Z is equal to 11. It means how many proton are there? 11 proton. This 11 is odd number or even number? It is odd number. And in case of odd number, what will be the number of neutron? Proton plus 1. That means proton is 11. So neutron will be 11 plus 1, that is 12. So what will be its atomic mass now? Proton plus neutron. That means 11 plus 12. So A is equal to 23. In this way, we can find the atomic mass of any element from 1 number to 20 number. And remember always, hydrogen is the first element where in hydrogen there is no neutron. There is 1 electron and 1 proton in hydrogen. So in case of hydrogen, atomic number and atomic mass are equal. So what is the atomic number of hydrogen? 1. What will be its atomic mass? 1. We have to remember this. Then 7 number, what is there? Nitrogen. Nitrogen is 7 number. This 7 is odd number, but we do not apply here the odd rule. We have to apply in case of 7 number even rule. That means there are 7 proton. By this rule, there should be 8 neutron. But no, here in case of nitrogen, number of proton and number of neutron are same like the even number. So what will be the atomic mass of nitrogen? 7 plus 7, 14. So in this way, we will be able to find the atomic mass of any given element or any given atom. So this is about the atomic mass. Thank you.